All right, welcome to The Explainer. Today we're going to pull back the curtain on a piece of tech that millions of us use every single day, but we probably never really think about how it works. I'm talking about the collaborative document. I mean, think about that for a second. Millions of people, one document, all at once. How is that not just complete and utter chaos? It really does feel like magic, doesn't it? Well, it turns out it's not magic at all. It's just an absolutely brilliant piece of system design. So, let's get into it.
Okay, first things first, let's just try to appreciate the sheer scale of this challenge. We're not talking about a few dozen people here. We're designing for over 100 million active users. That's insane. And you've got to understand, that number, that massive scale, it dictates every single decision we're about to make.
So here's how we're going to break it down. We'll start with the main problem, lay down the basic architecture, then get into the really tricky part, the real-time edits. After that, we'll see how to handle more than just text, and then we'll put it all together to see the final blueprint.
All right, Section 1, the collaboration conundrum. So before we write a single line of code, we really need to figure out what we're trying to achieve. What are the absolute non-negotiables for this system?
So these are the big three. High availability, meaning the service has to always be on. Low latency, your edits have to show up like instantly. And then there's this really interesting one. Eventual consistency. And this is crucial. It means we're okay if, for a tiny fraction of a second, your document and my document are slightly out of sync, as long as they eventually and very quickly resolve to the same correct version. This trade-off is the secret sauce. We're prioritizing speed and uptime over perfect, instantaneous sync. And that's what makes the whole thing possible at scale.
Okay, on to part 2, architecting the foundation. Let's start laying the first bricks and see how we handle all that traffic and the basic stuff.
So, when you make a request, the first thing it hits is a load balancer. Think of this like a traffic cop for the internet, making sure no single server gets buried in requests. After that, it goes to the API gateway. This is kind of like the main entrance, or the front desk. It checks your credentials, figures out what you want, and points you to the right department.
And one of the first things we do is split the work up. We create separate services for separate jobs. Creating a new doc, that's a pretty simple one-time thing. But editing, oh man, that's a constant, high-traffic, chaotic process. So we give them their own services. It's like having a quiet library for document creation and a separate soundproofed room for the crazy editing party. That way, the party can go wild without bringing the whole system down.
Okay, next big question. We need a place to store all the basic info about a document. Its title, who created it, when it was last edited. And this brings us to a major architectural decision. Do we use a classic, superstructured SQL database, or do we go with something more modern and flexible, like NoSQL?
And for what we're doing, NoSQL is really the only way to go. Why? Because we need to handle that massive scale we talked about, millions and millions of documents. NoSQL databases are designed to scale out horizontally. That means instead of buying one giant expensive server, you can just keep adding more and more cheaper ones. And since we don't need a bunch of complex connections between our data, the rigid structure of SQL is just overkill.
All right, but what about images or videos? The heavy stuff. You definitely don't want to be stuffing those into your main database. It would get slow and super expensive fast. So what we do is we offload all that to something called blob storage. It's basically a giant, cheap digital warehouse for big files. In our main database, we just store a little note, like a link that says, hey, the image for this doc is over there in the warehouse. It keeps things fast and cheap.
Okay, now we get to the heart of it. Section 3, solving real-time edits. This is the main event, the whole shebang. This is where the real magic happens. So how on earth do you let tons of people edit a document at the same time without it just becoming a jumbled, corrupted mess?
Well, the answer, and the absolute hero of this entire story, is an algorithm called operational transformation, or OT for short. This thing is just mind-bendingly clever. It's the secret weapon that makes all of this real-time collaboration actually work without everything just falling apart.
Okay, check this out. This is where you can really see the genius of OT in action. So let's say the text is, "Hi, Danny." Now you and I are editing at the same time. You delete the final I. At the exact same moment, I decide to add an exclamation point at the end. Now, what happens? The server gets your delete operation first. Easy enough. But then it gets my instruction, which was insert exclamation point at index 7. The problem? Index 7 doesn't exist anymore because you deleted a character.
A normal system would just break. But OT's smarter. It sees your operation came first, and it transforms my operation on the fly. It says, the document is shorter now, so what they really meant was index 6. And boom, the final text becomes Hi Dan, which is exactly what we both intended. It's incredible.
Now this leads to a huge efficiency gain. I mean, can you imagine if every time you typed a single letter, the system had to save and send the entire document to everyone else? It would be ridiculously slow and unbelievably expensive. The whole thing would just stop working.
Instead, and this is the really clever part, it only stores the sequence of operations. The database isn't full of different versions of the document. No, it's just a logbook, a list of instructions. Things like insert this letter here, delete these 3 words there. It's just a recipe for how to build the document at any point in time.
Yeah, this quote absolutely nails the concept. If you've ever used Git, it's just like a diff. We're not sending the whole project around every time, just the little bits that change. And because we're just sending these tiny operations, the system is incredibly fast and efficient. Plus, as a bonus, we have a complete history of every single change ever made.
All right, so that covers text. But what about everything else? Modern documents aren't just plain text, right? So let's look at how we handle stuff like formatting, comments, and all that jazz.
And this is where the design gets truly elegant, because it turns out everything is just another operation. You want to make some text bold? That's not saved as fancy text. It's just an instruction that says apply bold formatting to this range of characters. Adding a comment? Same thing. It's an add comment operation tied to a specific spot. Everything, and I mean everything, is just another instruction in the log, and it all gets handled by that same brilliant OT algorithm. It keeps the whole system beautifully simple and consistent.
So, one last piece of the real-time puzzle. How do all these updates get pushed out to everybody's screen almost instantly? The tech behind that is called WebSockets. So a normal web connection is like sending a text message. You send a request, you get a response, conversation over. A WebSocket is totally different. It's like starting a phone call and just keeping the line open. It's a persistent two-way street for communication between your browser and the server, so updates can flow back and forth constantly.
Okay, let's take a step back and look at the big picture. Here's the complete blueprint we've just put together.
So if you look at our key decisions, it all fits together. Right? We used microservices to keep things organized and prevent one part from crashing another. We chose NoSQL for its incredible ability to scale. We moved all the heavy media files to cheap blob storage to keep our main database lean and fast. And then, at the very core, we used that magic combination of operational transformation and WebSockets to make the real-time collaboration actually happen. Every single one of these choices supports the others, creating this powerful, scalable, and really responsive system.
It's pretty amazing, right? It really makes you think about all the other tools we use every day without a second thought. Behind so many simple interfaces, there's just this incredible level of elegant, complex engineering. So the next time you jump into a shared document, maybe you'll have a little appreciation for the hidden dance of operations that makes it all possible. It really makes you wonder, what other everyday tools are hiding this kind of magic? Thanks for joining this explainer.